So hello guys, welcome to another video, and in this video we're going to be covering a very important question from LeetCode, that is unique paths. Now it is a medium level question in which we have been given a matrix, like it's called the grid, and its dimensions are m into n. There are m rows and n columns. So you are situated initially like at the starting point, that is 0, 0, and you have to traverse. You have to find all the total number of ways, the total number of unique paths that you can get to reach this end point, that is the finish point that is situated over here, situated at the start, and you have to compute the total number of unique paths that you can get to reach this ending point. Okay, so here what has been given is that you have been given the dimensions, and you have to reach from the starting point to the ending point. Okay, that's great. Now let's come up to how we design our approach. So first of all, let's not take a very big array. We'll take a simple 2 cross 3 array. So m's value is 2, the number of rows is 2, and the number of columns is 3. Okay, it's perfect. So now what we do is that we simply know that we have to start from here, we have to end over here, right? So I will be explaining this question to you in 3 different approaches. Okay, so the first approach is going to be simple recursion. The second approach is going to be dynamic programming, in which I'm going to tell you about both memoization and tabulation approaches. And the third approach is going to be about like it's a very special and very efficient approach, that is a combinatorics approach. So these are the 3 approaches that I am going to explain to you. So first of all, let's come up to the recursion approach. That is the most basic approach that we can think of. So what we basically have thought of is that, like, if suppose you have this recursive, most of you must have heard about DFS traversal, right? In a matrix, how do you do a DFS traversal? So the nature of the DFS, or depth first search traversal, is basically that you are basically forwarding to a specific node, and then you will be forwarding in a single direction until and unless you reach your target position or any target condition that you might give. And once you do that, you are basically like, since it's all recursion, so it's automatically going to backtrack, and then it's going to follow another path, and it's just going to reach the end. And so every time it reaches the end, we might keep a variable that will increase when it reaches the end. So every time it reaches the end, this variable's value increases. So we ultimately get to know that what is the different like the total number of ways with which we can unique paths with which we can reach from the starting point to the ending point of the matrix. But this is a very time taking process, because as you can see, like, this is a very small matrix that I have made. If you test it with very large test cases, it's basically going to take a lot of time, right? Because it like again and again, like suppose I take I take a 50 cross 50 matrix. Okay, so like suppose it goes through all the columns once, it goes through all the rows once. Okay, again, so it reaches the end, then again it will have to come back, it will go through all the other columns. Okay, it will have to go through again all the other rows, it will again have to go through all the other rows. Like for every element, for every 50 element, it will have to go through all the other rows. And this is not all, right? Because we know that all there are various other combinations like this, like traversing through different cells and reaching the end. So like there are basically a lot of traversals that's going to be happening, and we don't want that. Okay, like we know that there are there are two possibilities for every case, that we can either like move down or we can move right. So this is specified in the question itself. Wait, let me show you that. Okay, so we can basically initially look the robot can move either down or right at any point in time. So that's what we are going to follow. So we know that at every point there are like 2 conditions that it's going to have. And DFS traversal takes a lot of time, and if for every cell we are doing a DFS traversal, now it's going to take a just a hell lot of time. So we are not going to discuss about that at all. Okay, you basically get to know, right, that what is basically that process, that this is the brute force approach. It's the most brute force approach that you need to tell the interviewer at the very first. So now we come to the optimization. So how can we optimize this? So you can say that like after reaching every cell, so I know that I have to either go, like after reaching every cell in this matrix, I know that I have to either forward to the right side or the down, right? Like I have to make a recursive call to the right side or the like the cell that is down. So like once I do that, like the result of this recursive function will basically be the total number of ways that can like through which I can basically reach the end from this next cell, right? So like what if for this thing I basically store, like suppose from the down array I get this d number of total ways that I can reach to the end, okay, and from this I get like r number of total ways through which I can reach the target node. So what if this r plus d, I just keep a like I just keep another matrix in which like for every cell, okay, for every cell I store this r plus d value, okay. Suppose I reach this cell once and I compute all the value, all the total number of unique paths, whatever it may be that it takes to like reach the target array. So once I get that this r plus d value for both the directions, so I can basically now store it at this cell. So the next time, suppose when I am traversing from this node, suppose, and I need and I come at this node, so I know that what is the total number of ways that can be covered from this specific node. I have it already stored. Now this process is known as memoization, right? So this is a dynamic programming approach in which you keep an array which is of the same dimension of the matrix that has been given to you, in which you can basically store like for every cell what is the total number of paths, unique paths that it can have to the target node, either to the right, like either from the right side of this cell or from the down of this cell. So we know this approach now, but in this approach also we require a lot of space, right? And also like we have to make a lot of recursive calls in this case, although like the time complexity of this case is also O of mn only. But suppose we don't want a recursive approach, okay, like this mn is actually quite lesser than the only recursion approach that we had discussed. That would have been a hell lot, but this mn has been reduced to like a very large extent. Like we have like when we have the time complexity of mn, it's actually a lot less than only recursion. So now suppose we don't want recursive code, we just want to like like there is a like your interviewer might say that you can't use the auxiliary space, the stack space that is used by recursion. If you can't use that, you have to go with an iterative approach, right? So what will you do if you need to go with an iterative approach? Now that's where tabulation form of the DP comes up, okay. So here it's not very hard, okay, it's not very hard to understand. You just have to visualize all the things in a very nice manner. So suppose you have any grid, okay, like in this in memoization approach, what we had been doing is that we had been storing the total number of ways in both the directions, the sum of the total number of ways for every cell, right? Here what we will do is we will not do that. We will not be like doing DFS and storing it. Rather we will be initially like we will like suppose this is our matrix, okay, I'm taking the small matrix only. Suppose this is our matrix. Okay, this is a bit too big that I made. So this is the matrix that I have, okay. So what I will do is I will initially, okay, I'll put all the this first row, because see, when I start with this this starting point, right, how many ways can I reach this one over here? I can reach this in one way, in one unique path only I can reach, right? How many ways can I reach this two in? This also I can reach in only one unique path. So what I do is the first row I initialize this as 1, this is 0, this can be 0, and this is also 1, because this also only in one unique way I can reach, right? So all this is I have initialized the 0th column and the 0th row as ones, okay, because there is only one unique path through which I can reach all of them. So that's done. So when I like forward, so now I will suppose this grid had been bigger, okay, this grid had been one dimensional bigger. So what I would have to do is that now this also I would have set as 1. So I would have to simply do, now let's name this matrix as DP, okay. So I would have to do basically is that the dp of ij, like suppose I is the rowth number, like 0 indexed rowth number, and j is the 0 index this column number. So what I would have to do is that for every value of row and column, I would have to check that what is the previous row value and the previous column value. See, I am not really explaining you from the very depth point of view, because obviously if I keep on explaining this DP part over here, then it will be a very long video. So that's why I'm just telling you that what is the basic structure that we'll be using here. How will we be dividing this into sub problems? So here what we are doing is like the very basic intuition that you get from here is that, like, for every like cell there is one specific coordinates I and j, right? So for every specific cell, you are making the sum of I minus 1 j and I and j minus 1, right? So what does that mean? This I minus 1 j basically is this value over here, right? So this means that like you can like through this way, like through this this part, you can reach here in one specific way, right? That is true because this was initialized as 1, right? So now this way you can reach in one passing through the previous row, you can reach this at one single unique path, right? But like you also need to consider this path also, right? Like passing through the previous column. So while passing through the previous column, you can also reach this point in one unique way, right? So there are 1 plus 1, that is 2 unique ways in which you can reach this cell over here, right? So that's what exactly we are doing over here. Like you just need to visualize this like this I minus 1. Don't think of it just like the loop point of view, that we are just looping I from 0 to the number of rows and we are looping j from 0 to the number of columns. That is not that is not all. You have to imagine that what is the essence of every cell in the DP matrix. So the essence of every cell in the DP matrix is basically like signifying one specific cause. Like here for every like DP cell, we basically know that what is the like the total number of ways that we can reach this specific cell from the like starting cell, that is 0, 0. So now suppose we like the significance of the value of dp1 2 is that what is the total number of unique paths that we can have like if we have to travel from 0, 0 to 1, 2, first row, second column, right? What is the like total number of unique paths that are possible? So that is what dp12 signifies. So here dpij will signify that what is the total unique number of paths that are possible that we can reach from 0, 0 to I, j. That's all you have to know. So that, as I just showed you, that the simple way of doing like visualizing this is that you can either reach from the top or you can reach from the left. Now see, why I'm saying about top and left, right? In the question it has been given about bottom and right only, right? You can move in only 2 directions as it is given in the question. But tabulation, see, DP is basically 2 ways, okay? This memoization that is told you, that is basically, it is the straightforward path, okay? Wherein we are, just like moving from the very beginning and we are going to the very last. But, the very reverse approach is basically tabulation, okay? So, this is something that like this is memoization is something that is also known as bottom-up approach, and tabulation is also known as top-down approach. So bottom-up approach, in the bottom-up approach, we start from the very scratch of the problem, okay, and we like keep building all the data, like we started memoizing all the data, and we just like kept on memoizing data and accessing them. But then in this one, we are basically like having a set of data, and then we are going in the reverse direction, okay? We are not really like storing a lot of data and doing that. We are just processing the like we are just keeping some initial values through our guess, like this guess that we made, that's that from 0 like in the 0th row from this source point 0, 0, every column I can reach in the 0th row, every column I can reach in one unique path. Like this is an initial hit or an initial guess that you need to make while initializing your DP array. So also in the for like 0th column, the same guess. So that's how you do it. So this is basically the reverse approach. So if it is the reverse approach, in that way, in that case, what we need to do is basically that if in the straight approach, we had been given in the question that we can move in either bottom or the right side. So in this in this approach, we will have to always consider from the top, that is opposite of bottom, and left, that is the opposite of right. So because one more reason for this is that if we are traveling from 0, 0, right, like I told you, the whole essence of this dp I, j is that if we travel from 0, 0 to I, j, what will be the total number of unique paths that are possible for us. So if we are moving from 0, 0, essentially we have to move in right and bottom direction only. But when we are storing the all these data, all the possibility for all the cells, like all the total number of paths for all the cells, we are storing it in a reverse direction. That's why we are considering the top element and the left element, the sum of the top element and the left element basically. So that's how I do it. So I hope I've been able to give a very brief approach. If you want to know more about it, you can just watch some DP videos in which they explain that how memoization is different from tabulation in DP. So that's all we did. So this way, as you can see, let's clear this mess a little bit. Okay, so so this column, this row is initialized as 1, this is 1, and this is 0. So here 1 plus 1 is 2, right? Perfect, this is 2. In this cell again, I will have the sum of top and left, that is 3. And in this bottom, here over here, I have the sum of this and this, that is 3, and here I have the sum of 6. So see, if it is a 3, 3 matrix, okay, and if you need to reach from this 0, 0 to this 2, 2, like I had this, right? This is my target cell, right? So if I have to reach from 0, 0 to 2, 2, I have to move through these 6 unique paths. So I will have 6 unique paths throughout. So this is how we found out this using tabular DP. Now coming up to the combinatorics part. So combinatorics part is actually the most exciting part over here. Now that's what I am going to be explaining you the code for. So in this question, basically, as we know, there are simple matrix that you can use in order to, very simple maths that you can use in order to realize the whole question properly. So if you can see properly, let's erase this also, and let's draw the new matrix. So if you can visualize properly that, if suppose this is my target cell and this is my initial cell. So if I need to reach the target cell, suppose I take this path, okay? Suppose I take this path. So how many right direction did I have to move? Just tell me that. I needed to move one right direction. There is one R, and one D. This is right, R is right, and D is down, okay? So I had to move 2 rights and 1 down, right? So this was RRD. Suppose now suppose I have to I go through this path, okay? So I have to move 1 down and then 2 R's, right? 1 down, 2 right. And if I move through this path, suppose that is, this is 1 right, okay, 1 down and 1 right. Can you observe a pattern in this? That the number of R's and the number of D's is never changing. It's the same. Here number of R is 2, here also it's 2, here also it's 2. Number of D, here also it stays 1, here also it stays 1, here also it stays 1. How is that? That is because, as you can see properly, that for reaching from 0, 0 to the ending, that is this 1, 2 cell, we have to, essentially, whenever we move in a matrix, we have to reach the last column and the last row. We know that we have to travel that many columns and that many rows, right? So essentially, if suppose our m here is 2, right? Number of rows is 2 and number of columns is 3. So if we are already present at 0, 0, so 1 and 2, we have to travel 2 times, right? That is okay, so this is basically okay, so 3 minus 1, because number of columns, and here we have to travel only once, that is 2 minus 1. So in total we'll have to travel 2 minus 1 plus 3 minus 1 times, right? Like if you can see properly, that here the total number of sections of this unique path is always 3, right? 2 plus 1 3. Here also, as you can see, this is just 2 plus 1 3. It's always 3, so this is always going to be constant. So this is basically like m minus 1 plus n minus 1, right? So we always know that whatever path we take, whatever unique path we take, whatever matrix dimension we have, the number of total sections of the path is always going to be m minus 1 plus n minus 1. Is that clear? So it comes to m plus n minus 2. So that's fixed, that the total sections, or you can say the total number of directions that I'll have to decide at every cell is basically sums up to m plus n minus 2. That is number of rows plus number of columns minus 1. So now what I have to see is that if I have m plus n minus 2 steps that I will take, okay, now I know that I see also one thing you can notice, that as I said, that for reaching from 0,0 cell to suppose you have to reach from this origin cell to the last column, right? You always have to move, if the number of columns is n, you will always have to move a minimum of n minus 1 steps to move the last column. That is just fact, right? That is just maths. You have to have that number of steps in order to reach the last column. So essentially we know that whatever may be this number of steps, we always have to select n minus 1 and m minus 1, like n minus 1 number of r's and m minus 1 number of d's. Okay, so as you can see here, that here the number of r's, like here the number of r's is basically 2, right? Number of r's is here 2, that is m is number of r's here is 2, right? So this is basically n minus 1, that is 3 minus 1, that is 2, right? Here if we put 3 minus 1, so that is the number of r's that we have actually over here, and here m minus 1, 2 minus 1, so d has one appearance in every in every combination of steps. So as you can see, d has only one appearance, right? So that's what it signifies, that whatever may be the number of steps, from this we'll always have to choose m minus 1 d's and n minus 1 r's. So this is always fixed, right? Now this is the interesting part. Okay, what does the theory of combinatorics tell us? That whenever we have a total number of cases, okay, like suppose we have this we have 5 cards, and we have to choose 3 cards, okay, from there. What is the number of unique choices that we can make? That is 5c3, right? Because 5 is the total number of cards, we have to choose 3 cards from there. So that is the total number of choices that we can make. The same way here also, if the number of total steps are m plus n minus 2, right? And we have to make the choice, we can see, you can tell me that it may be different, like if we take the choice for m minus 1 d's, that is m minus 1 down steps, and n minus 1 right steps, but that is wrong. You can see that the value of m plus n minus 2, m minus 1 will be absolutely equal. If you do this m plus n minus 2, c n minus 1, it will be absolutely equal. We can actually calculate that over here and see also. I'll show you that, but let me first tell you that clearly, that if you didn't understand, m minus 2 is basically the total number of steps, okay, that we have to encounter if we want to reach from 0,0 to m minus 1 n minus 1, because essentially m minus 1 is the coordinate of the ending cell that we have, and n minus 1 also is the coordinate, like the column coordinate of the end, the target cell that we have. So essentially for moving from 0,0 to m minus 1 n minus 1, we have to have a total of m minus 1 plus n minus 1 steps, that is m plus n minus 2 steps, right? So that only, from this m plus n minus 2 steps, we have to always select m minus 1 d's and n minus 1 r's. I'm not saying or, okay, I'm saying we have to always select m minus 1 number of Ds. Okay, you have to always select m minus 1 number of Ds, and you have to always select n minus 1 number of Rs. That is fixed. So you can either calculate the value of this, okay, to get the total number of unique ways that you can do this, and the total number of unique ways that you can do this will actually be the total number of paths, unique paths that you can have, right? Essentially that is true, because like suppose you have been given like 5 number of cards, right? And you have to choose 3, like you have to make combinations of 3. How many unique ways that you can do it? That is the actually way that, like, if I ask you that you have to reach from 0 cards to 3 cards, okay, you have to move from you have to shift from having 0 cards at your hand to 3 cards in your hand, and I have kept a bunch, like a pack of 5 cards in front of you. So how will you choose it? You will choose 1 by 1 card, right? And you will make exact, like from the deck of 5 cards, you will have to pick exactly 3 cards, and you have to make a choice. What will the total number of combinations that you can do? That is 5C3, right? So that's exactly what we are doing over here. Like from being at 0,0 to being at m minus 1, n minus 1. We'll have to basically explore all the specific steps that we encounter. And for exploring all the specific steps, we have to select either like from those m plus n minus 2 total number of steps, we always have to select m minus 1 m minus 1 Ds, that is m minus 1 number of that is the total number of the column rows that we have to select that minus 1 number of Ds, and always the total number of columns minus 1 number of Rs, that is rights. So we always have to do that. So that's why the answer to this m plus n minus 2 c m minus 1, or the answer to m plus n minus 2 c n minus 1 is going to give us the final answer for this problem over here. So I'm going to show you that how like both of this have the same value. Like here the value of m is it's 2, right? And the value of n is 3. So m plus n minus 2 is what? M plus n minus 2 is 5, like 5 minus 2, that is 3, right? And here we have to do 3c m minus 1, 3c1. Okay, what is the value of 3c1? 3c1 value is 3 only. And here again, if we try to do m plus n minus 2 c n minus 1, what is n minus 1? N minus 1 is 2. So if we do 3c2, you can also see that 3c2's value is also 3. So essentially we can say that both of this we can do, because it's not either of the choices that we need to make. That either we need to take m minus 1 we have to take m minus 1 Ds, or we have to take n minus 1 Rs. It's not like that. It's not the or, it's and. It's always and. Like as I showed you all the combinations, it can either be RRD, it can be RDR, or it can be DRR. So every time you always have to take n minus 1 number of right directional steps, and you have to take m minus 1 number of down directional steps. So you always have to do that. So now let's just write the code for that. So first of all, we'll be basically initializing the total number of steps that we have, that is m plus n minus 2. Then we would take the last row as m minus 1. Okay, so that is like the number of right directional steps that we need to take. Sorry, the number of down directional steps that you need to take. So we'll initialize this with D, let's say. So then we take our answer, say as 1. Okay, now I won't be explaining you that why I wrote this formula for finding out the combination between like two numbers. If you don't already know about this, you can like watch any material that is available online. Like I won't be explaining exactly this. So the formula for this is basically answer into the total number of ways, okay, total number of ways minus the ways that the number of choices that we need to make, plus I, and when it is divided by I basically. So now we need to return this as an integer, right? So we can check. Okay, let's run the code. So this R is not, okay, fine, this is D, right? So we just keep it as D. So as you can, okay, this R is again, okay, sorry, my bad. So as you can see, the sample test cases are passing. So let's run all the sample test cases for once. So as you can see, all the sample test cases are passing over here. So if we submit it right now, so fine. So it is basically you have to remember this, that in this combinatorics part, all you have to remember is the total number of steps and the number of the down directional steps and right directional steps that you always need to have. Like if in case I need I replace this with basically the number of right directional steps that we have, it would have essentially been the same, because as you can see over here, if I replace this with R, okay, that is n minus 1, it would have essentially been the same and it would have given us the exact same answer. So as you can see, if we submit it, so it basically gives us the exact same answer. So that's what the beauty of Combinatorics is. If you have not already studied about this, you can go and watch some videos on this. You can go and watch out that what is exactly the code for finding out the when you're given a total number of choices, what is the exact formula with which you can find out the number of ways in which the number of choices can be made. So that's all for this video. I hope you enjoyed it. If you've not done this question, you can attempt this question. There is also another variant of this question which includes obstacles in the path. Okay, now this question didn't actually include obstacles in the path, but that would include obstacles in the path, and that question we'll have to do through a little bit of backtracking along with the DP. So that's all for this video. If you find useful, you can go to my GitHub repo, that is RKARKAYYY LeetCode problems. So you can basically go here and you will find topic wise sectioned problems for each and every data structure and algorithm. You can just go there and you can check the code for all the problems that I have attempted till now. Okay, so that's all for this video. If you have any suggestions, you can put them in the comments, and if you have any requests or problems, I will be happy to solve them in my upcoming videos. Thank you and have a nice time.